Alright, so we're going to do a weight example here. I just wrote the equation. The weight of something, which is a force in newtons, is equal to the mass, which is right here, and that's measured in kilograms. And of course, little g, since we were talking about weight, it's the acceleration due to the Earth, which has a value, a well-known value of 9.8 meters per second squared. All right, so I'm gonna give some values, and we'll calculate. Let's calculate an answer. So let's say that that we had a weight equaling, let's say 15 newtons, and we want to know the mass. So we're looking for m. M equals question mark. So the first thing that we do is we check to make sure that everything's in the right units. So G is already well known, 9.8, that's in the proper units. The weight is in the proper units, it's 15 newtons. And then so we just take our original equation, W equals M times G, and we solve for M. And you're going to find a lot of these problems that we're going to do. This is very similar to the kind of thing. I mean, obviously it's different equations. So, to get the m by itself, we're going to divide both sides by g. So m is going to equal the weight divided by little g. And then we'll put the numbers in now that we have that equation. I hope everybody understands where that comes from. So all I did is divided both sides of this equation by a little g. So the little g, it disappears on this side, it cancels, and then it's in the denominator over here. Alright, so let's put our numbers in. So it's going to be 15 newtons divided by 9.8 meters per second squared. Alright. Sorry. Yeah, let's erase this little part here. Okay. So, alright, so we'll get our calculator out and just say 15 divided by 9.8 is, I get 1.53. So, it depends on where you want to round this. 1.5 is perfectly fine. So this is going to equal, oops, we need a little bit thicker. Alright. So it's going to equal 1.53. Sorry, there's the 3. And what are the units? So a newton is really a kilogram times a meter per second squared. Now how do I know that? Because if you look at the original equation and you look at what the units are, 1 newton, like just think of the equation in terms of units. So if I put like an equal sign right here, then a newton is a kilogram times, so this is times, a meter per second squared. So a newton, you're dividing by meters per second squared. Whoops, I forgot the seconds. And so the meters per second squared is going to cancel, and so this is going to be 1.53 kilograms. Alright, so there's our first example. Alright, for our second example, this time I'm going to give you the mass. So let's say we know the mass is, I don't know, how about 200 grams. 200 grams. And we want to know the weight. So what is the weight of an object on the surface of the Earth that has a mass of 200 grams? Weighs how much? And remember, our equation, mass has to be in kilograms. This is not in kilograms, right? That's in grams. So what we're going to do, and I want everybody to get used to doing this, to do these conversions. So here's how we do it. There are 200, so we have 200 grams, and if you look at the metric prefixes or the video on metric prefixes, you'll know that in 1 kilogram there are, so we always do this like a fraction, 1 kilogram there are 1,000 grams. 1,000 grams. And I'll often write that as 10 to the third grams, which it means the same thing. So notice the grams will cancel here, and so you just take 200 divided by 1,000, and so that's just 0.2, right? So 0.2 kilograms. So that's what 200 grams is in terms of kilograms, of course. And so now we can solve the problem. So the problem is, what's the weight? So the weight, and this is also something that you'll often have to do, is just do a quick conversion and then plug it into the equation, of course the proper equation. So this is going to be the mass times gravity, where the mass has to be in, well, gravity being the acceleration due to gravity. Anyhow, so this is going to be 0.2 kilograms. Oops, that didn't come out. Okay, kilograms times 9.8 meters per second squared. Okay, so remember, a kilogram times a meter per second squared is going to give us newtons. So let's see what that is. I'm just going to do this on my calculator. 0.2 times 9.8. I get 1.96. So 1.96. And since it's kilograms times meters per second squared, it would be newtons. Alright, so there's our second example. And really that's, you know, the lesson here is, if you know the mass, turn it into kilograms, you'll know the weight. If you know the weight, and it's in newtons, you can figure out the mass just by dividing by little g, like we did in the first example. Alright, so